I'm Carly, and this is
Bella.
And we did the bouncy egg. The problem is we are trying to solve is can we remove an eggshell then make it bounce?
The hypothesis was I think it will work because the vinegar will make the egg bouncy when the egg is in the vinegar.
The materials are a raw egg, glass jars, or paper cups, and vinegar.
The procedure is first you place a raw egg carefully in a jar. Then you put vinegar in the jar that covers the whole egg. Lastly, you let the egg sit for 24 hours and you take it out. Take it out, rinse it with water, then bounce the egg 1 to 2 inches. Then let it go. Make sure you wash your hands after.
Results. The results are that the bouncy egg took 24 hours to do. We also figured out if you bounce it too high, it'll break. It also took the eggshell off the egg.
The conclusion, so all in all, it worked because it had to sit for 24 hours so it could bounce. And be prepared. It may break, so wash after.
Okay, so the ingredients that you said we need vinegar, eggs, and cups, whatever.
It doesn't really matter what cups.
Yeah. So first you take a random cup and put.
That's empty.
That's empty.
And take an egg.
And you take an egg and put it carefully. Make sure there's no cracks. Put it carefully in there.
Then you take the vinegar
and slowly pour it so it covers the whole entire egg.
So when it's done, it should look something like this.
Yes.
And then you let it sit for 24 hours.
Let it sit for 24 hours. We did 4 of them.
We have 4 eggs that have been sitting for at least 24 hours.
At least 24 hours.
So they will start to look a little bit foamy, so it's fine if they look foamy.
Yeah, and it'll look like, yeah. So then we take one of the eggs out.
And this is the first egg that we had. And then we have...
You put it gently into the water so it can wash off.
And this is a cup just of water. And then you leave it in there for a couple seconds. And then
you
take your plate.
It could be, you could use the table, but you might want to make sure you use the plate first so it doesn't, if you get put it for a long while, take
it may break.
Yeah, it may break. So
then this is what it looks like
when it's done.
And then we have paper towels, and you will take the egg.
If there's more eggshell on it, which
it's
is
fine.
Some of it is still on here, but it's okay. You bounce it 1 to 2 inches.
And then it will start to bounce. And then you'll put it on the paper towel and it should get off a majority of the eggshell.
So you just put it in water for a little bit and then...
But don't press too hard, otherwise it may break.
Yes. And yes, we have tried before. Bouncing a pie does not work well because it's splattered everywhere, so don't try this. And you just bounce it. So there's your bouncy egg. Bye.
I did growing ice. The problem, can you grow ice from water? The hypothesis. I think it'll work because ice is made out of water. Materials: ice, a cup, cold water, and food dye. Procedure: 1. Put a water bottle with food dye sideways in the freezer for exactly 2 hours and 45 minutes. Get a cup of ice and pour the cold water in the ice. The ice should grow almost instant upward, then tall. Results. It was a little bit of a fail and success. It growed a little bit, but also not a lot, so conclusion. It happened because the food dye water was not cold enough to grow.
Then take the cup, take ice, and put it in the cup. And then the cold water with food dye. And slowly pour it. And then it grows.
Hi, this is a water vacuum.
Okay. The problem is what we want to see if the water will get sucked off by the match slash candle in the glass.
Now I have to pop this. I think it's going to work because the smoke of the match is going to suck up the water, and the water chemical will go through a tiny hole, but can't escape.
Materials. You need a tall glass, a candle, water, a small ball of clay or cotton ball, and a flat plate.
Process. Stick the bottom of the candle slash match into a bowl of clay slash cotton. Then fill the glass half full with water and pour the water in the shallow dish. Light the candle, invert the glass over the candle, and set the glass mouth down into the water.
Results. It worked and the water got sucked up into the cup.
Conclusion. The reason why the water got sucked up is because the smoke is lighter than the water, and the smoke sucked up the water. You can see we already fill up the dish. Rain's going to get the match. Stick in the center of the cotton ball. It might take a little bit. And if it folds, get a new one.
Set it down. Keep going.
This one's golden. There you go. Beneath the then you see our teachers letting the match.
Set it back up.
Then you invert the glass over there and watch as the water rises. And those bubbles we haven't seen before. Then, once you're done, take off the glass. Wait, what? This has not happened. Oh!
Okay.
It smells like this. And it's also a suction cup.
Yeah.
Hi, I did tie-dye milk. Problem. In this experiment, you will investigate the effect of adding food coloring and Dawn dish soap to milk. Hypothesis. I think the dish soap will react with the milk and the food coloring. Materials. Dish, milk, food coloring, Dawn dish soap, and a Q-tip. Procedure. Put milk in the dish. Add drops of food coloring to the milk. 3. Dip your Q-tip into the Dawn dish soap. 4. Dip your Q-tip into the milk and food coloring mixture. Observe the reaction. Step 5. Be amazed. Results. The Dawn dish soap reacted to the milk and the food coloring. It made a really cool design. Conclusion. The soap reacted when it touched the milk and food coloring. The food coloring spread out quickly and made designs. First, you put the milk into the plate, and then you get all the drops of food coloring. And you can do however much you want. I'm just going to put some. And then you get the Q-tip and put it in the Dawn dish soap. And then you put it in the middle. And it makes a really cool design. We did, for our science project,
The
was
summer slushies. Problem: waiting for summer may take a long time. Plus, why waste money when you have all the ingredients at home?
hypothesis. What we think about the slushies, or what's going to happen, is that the salt may take chemicals from the ice and freeze the juice, and the ice shaves it down to make it like a slushie.
Materials: you will need 2 cups of ice, 1/4 of salt, 2 cups of juice, 2 bags, one smaller than the other, and lots of time.
Procedure. First, take any kind of juice and put it in a small bag. Don't fill it all the way though. Next, get out all the air in the bag and put it in a bigger one. Next, put ice on each side of the bag. Then put the salt on the ice and wait for 30 minutes. And then you have a slushie.
Results: the ice cooled and froze the juice, and the salt helped the ice shave it down.
Conclusion. The reason why it did work was that the salt did kind of push the ice to freeze the juice. And the salt also made the ice crush, it like moved the ice and then it crushed it down. And so here we're going to do the experiment. We take one small bag. We choose rationed fruit punch. And we dump it all in here. We're going to add one more. Then we're going to get all the air out. Which Damon's going to squeeze the juice out of. Next, we take a bigger bag and put the bag in this bag.
Next, you take a bunch of ice and put it on each side.
We couldn't get the cups, so if you don't have cups that you can use to put the ice in, then what you can maybe do is just fill it till most of it is covered. There you go. Next, since the bottom fell off, so we're going to just take salt and then sprinkle it on. You have to take a lot of salt on it. Next, we make sure all the air is out, and then we close it. Next, we shake it up for about like 30 seconds. 10 minutes.
You can cut there.
It's really good. This has been sitting for 20 minutes and it is completely frozen. What we did with this was actually we put it in like a little freezer to help it freeze more, because if we didn't, it would take like 40 minutes. And so it is like a slushie, it is crunchy, it's kind of like ice cream, and it is actually really cool. We're going to taste test this. Oh,
my gosh.
Ready?
It's so good.
Yeah. So I did a volcano. The problem is, will mixing vinegar and baking soda cause a chemical reaction? Hypothesis. I think this will work because I think when baking soda and vinegar gets mixed, it might cause an effect of eruption or a chemical reaction. Materials. You need a spoonful, flour, water, paper, cardboard, baking soda, and vinegar. Procedure. First you take some cardboard tube or circle, then hot glue it to a cardboard area. Then take flour and water and mix it into a bowl and mix. Put it into a bowl and mix. Then take strips of paper and dip it into the flour and water. Then put as many as you like on the cardboard tube. Then let it dry. After, paint it. Then once it's fully dried, add some baking soda in the tube. Then add vinegar. Then it should erupt. So I'm going to do mine. So first we add the baking soda into this tube. Oh goodness. I'm going to need a lot since that's what's going to. Okay, so now I take the vinegar and I'm going to pour it in. And that's what should happen. So, my results are the volcano erupted and went down the volcano, as you just saw. And the conclusion is when baking soda and vinegar gets mixed, it makes something like foam or bubbles, or a chemical reaction. And that's how I did my volcano.
I did the underwater volcano, and the problem is, can I make a volcano? My materials I use is a small clear glass bottle with a narrow mouth, a large clear container that is at least 5 inches taller than the bottle, 3 feet of string, food coloring, hot water, and cold water. Hypothesis. Yes, I do think that the ink will float to the surface. Procedure. Begin with a small glass straw with a narrow mouth. Cut a long piece of string, 3 feet, and tie one end around the mouth of the jar. Then thread the other end through the other side of the mouth of the jar. Tie that end into a knot. Ensure that both knots are tight and cut off any excess from the end of the string. And my conclusion is, when I mix the hot and cold water together, it pushes the dye out of the jar, or you cannot see the cold water and the hot water mixed together with the dye. So, you cut 3 feet of string. You take this, and you have to fill this with hot water, and fill this with cold water. So you take this, tie that, and then you tie it into a knot like that, and then you turn it around. You take the other end, and you kind of like do it again, but like right here. So like you can change it, like, so you do that, and then you knot it again. Okay, so then you knot it, and then you take both ends right here and cut it.
And then it's like this. And then you take red dye, put 10 to 15 drops in there. Okay, then you take the string. Then you take the big tub of cold water. You take this. And then the ink will come, the food coloring will come out and it will create a volcano underwater.
Hi, me and Emma's experiment is elephant toothpaste. The problem is, can you mix hydrogen peroxide and yeast to make a chemical reaction? Hypothesis. I think that it'll explode the plastic bottle and come oozing out. I think this will happen because of the reaction of the dish soap and the yeast mixing together and the dish soap making the yeast rise and explode. Materials. Hydrogen peroxide, dish soap, warm water, soda bottle, container, measuring cups or cup, food coloring, dry yeast, safety glasses, tablespoon. Procedure. Put on safety goggles. Ask an adult to pour hydrogen peroxide into an empty soda bottle. Add 10 drops of food coloring. Add 1 tablespoon of dish soap. Swirl to mix. Add a few splashes of warm water. Results. So what happened was the hydrogen peroxide made the other chemicals react and foam out the bottle. It didn't really work. Conclusion. It did not explode because it went too slow. It went too slow because we used too little hydrogen peroxide. Okay, so this. Safety goggles. Oh, yes. Glasses. Next, we need to ask an adult to pour hydrogen peroxide. We need 3/4. 3/4. Last time we only used 1/4. We need to use 3/4 of hydrogen peroxide. And maybe it'll go faster. Just maybe. Next, we need to break into pieces. Now we need to add 10 drops of food coloring. We're going to use red and blue. Okay, I'll use red. To do this, you'll have to remove the funnel. Now we need to add 1 tablespoon of dish soap. Get the funnel ready. Actually, I don't think we might need the funnel. I need it. No, I don't. Now swirl around the bottle to mix it. And then, now add 1 tablespoon of warm water. And now add it to the bottle. No, we added. Oh yeah.
And now you need to add dry yeast. You might need scissors. Now add dry yeast to the warm water. Then mix. I think we might need a little bit more water. We might need a little bit more water. Okay, that's good. Continue mixing. Then then you might don't want to use the funnel for this. Yeah, you want to use the funnel for this. Oh, there's no more. It should start to slowly rise. Okay, it's still going slow. It's not even going. Can we restart?
That's our science experiment.
It's been 2 minutes and now it has risen.
Hi, I'm Zoe, and my experience is bedtime. Problem: I need to power our clock and I don't have a battery, so I have to use a potato. Hypothesis: I think that the 2 forks and 2 sinks make electric currents when connected with the wire. Then the electric current goes to the clock through the wires. That makes the clock work. Materials: 2 zinc plates, 1 LCD watch, 1 connection wire, adhesive tape, 2 forks, 1 potato. Procedure: 1. Connect the red wire on the watch to a fork using adhesive tape and the black wire to a zinc plate. Get another fork and zinc plate and connect them with the connection wire, also using tape. Insert the forks and zinc plates into the potato to activate the LCD watch. The watch should start blinking. Results: the potato made the clock turn on from all the electric currents the 2 forks and 2 zincs were making when put into the potato. The wires had to be taped on the forks and zincs correctly. One wrong move and it would not work. I had to be very careful where I put them. When the clock blinks, that means it worked. Conclusion: while the zincs and forks were connected, it made a reaction which made electricity. It went to the clock from there using the wires. At first it did not work because it was connected wrong. When it came to the clock, the electricity spread into it. So, connect the red wire to a fork. And then the black wire to one of these zincs. And then connect this. put it all into the potato. And there we go. It's not.
We did a rainbow plate problem. We are trying to solve to make a rainbow from M&Ms and water.
Hypothesis. We think it will work because keeping the pencil in between it shouldn't mix.
Material: M&Ms, candy, and rainbow colors.
Procedure. Step 1. Set out a plate of M&Ms and let the kids sort it themselves. Step 2. Carefully pour water in the center of the plate so it just covers the candy. Do not shake the table.
Result: it didn't work because we didn't have enough water and it didn't have enough water on the M&Ms.
Conclusion. It happened because we didn't have enough water on the M&Ms.
Our project, so we put the water in the middle.
And there we have the M&M rainbow. Three minutes later.
Hi, I'm Staley and I did the floating grapes. So problem to see if sugar will make water dense enough to support a grape. Hypothesis. I think it will work because sugar makes it very dense, so I think it will support a grape. Materials. 3 cups, water, sugar water, and 3 grapes. Procedure. Fill the first cup full of water, the second cup full of sugar water, and the third cup halfway full of sugar water, and the top half with normal water. Then put a grape in each. Results. The first one sank, the second one flowed, and the third one flowed in the middle. Conclusion. The normal water wasn't dense enough to support the grape, so it sank. The normal water but floated on the sugar water. So I'm going to do my experiment now. So this is the normal water. We're going to see how that worked. So it just sank. This is the sugar water, and it floated on top. And this is the half and half, and it's floating below the surface here. So yeah, that's my experiment.
I did coloring carnations. Problem. I wanted to see the reaction of the flowers changing colors. Hypothesis. Yes, because I think the food dye will work and it will change the flowers' color. Materials. Food coloring 2 tall glasses that are the same size and pour water into them. Procedure. Put the flowers in the water and then put the food dye in and then wait overnight to see how it changes. Results. The flour turns the color of the water and changes the color of the flour. Conclusion. It works because the food dye and the flowers, the food dye goes up the flowers and it changes the color of the flowers.